12, and 13. How do you find the average value of a group of numbers? What do you do? Yeah, so the average is going to be the sum divided by what? Yeah, so you did this, and you divided by, what should we divide by? 6. So for average, you're going to do the sum of all what? Elements divided by what? Number of elements. So someone take out your calculator and do this. Please just do that for me. So what do you get? 5, 6, 7, 16, 28, 38, 41 divided by 6, I think. Is it 41? 42? Did I miss something? 42 divided by 6. So what's that come out to be? 7? Nice. Okay, so let's ask a similar question. It says, suppose you go 100 miles in 2 hours. Suppose you go 100 miles in 2 hours. What's your average velocity? If you go 100 miles in 2 hours, what's your average velocity? Yeah.
50 miles per hour.
Yeah, so you have 100 miles in 2 hours. So that's going to be 50 what? 50 miles per hour. 50 miles per hour. What you've done effectively there is the same thing. Even though it seems a little different, you've added up all of the instantaneous rates of change and divided by the total amount of time. The total amount of time. So let's say, though, I asked you this one. I made it a little bit more complicated. But what do you know? What does this mean? If you don't know the velocity function, you know something that you know some result that you can do with the velocity function. You don't know the velocity function, but you know we went 100 miles. How do you go from velocity to distance traveled? How do you go from velocity to distance traveled or displacement? What do you do to velocity to get to displacement? You integrate. So if I integrated velocity from 0 to 2, and you put a little dt here, what is that going to equal? What is it telling you? Equals what? It tells you equals what? Equals 100. So you don't know what the velocity function is, but what do you know? You know that if you integrate the velocity, you'll get 100. That's not enough to know what the velocity function is, but you now know that the integral from 0 to 2, or from 2 to 4, in 2 hours, right? It's just we picked 0 to 2 is going to be 100. And what did we do with that number 100 to get the average velocity? What did we divide by? Time. We divided by the total amount of time passed. We divided by the total number of time passed. So what did we actually do? Another way to think about this, does it say from time 0 to time 2? Does it say time 0 to time 2? No, it just says in 2 hours. So if we started at time, let's say A, what would be the end time? No, if we go 2 hours from A, what would the end time be? Yes, A plus what? 2. Because what's the difference between A and A plus 2? 2. So what did we do here? We got 100, but to get the 50, we divided by 100 divided by 2. Where does that 2 come from? That's the total time. That's the same thing as dividing by what? A plus 2 minus what? A. So what did we do actually? What did we do? We did this. I'm just doing the super general form so you can see it. We did this, and we ended up with what? What was our final answer? Because we know that this is 100, right? Correct? What's A minus 2 minus A? What's A minus 2 minus A? 2. So what does this simplify to? This simplifies to 1/2 times 100. So what is that? 50. So let's go down here and do the same thing. So do we have the velocity function this time? Do we have the velocity function this time? So what are we going to do to the velocity function? What are we going to do to the velocity function if we want to find this average velocity from 0 to 5? We're going to integrate it from what to what? It tells us that. From 0 to 5. So we're going to integrate t squared plus 1 from what? Oh, from 0 to 5. And what are we going to put out front? 1 over what? We're dividing by the total time. What is the total time? 5. So how do you get 5? It's from 0 to 5, so it's pretty straightforward. It's going to be 1 over what? Well, 5 minus 0. I just want you to write out the whole thing. 5 represents the end time, and what does 0 represent? The start time. Do you have to start at time 0 to do these averages? No, it could be times 7 to 12. And if it was from 7 to 12, you do 12 minus 7. So what does this equal? This equals 1 over 5 times the integral from 0 to 5 of t squared plus 1 dt. What are you going to need in order to figure this out? What are you going to need right now to figure this out exactly? Calculator. Use your calculator right now and figure that out. Give me it to 3 decimal places. Give me it to 3 as x squared plus 1, and then you'd have function int of what? y1 comma x comma 0 comma what? 5. That should equal 46 2/3. And then what do you multiply it by? 1/5. There's your fraction, 1/5 right there. So the units on this would be feet per second. Yes, that 46.66 represent, what is this? That is the total what? Total displacement. Total displacement from 0 to 5. Time equals 0 to 0, not 0 equals 5. From time equals 0 to time equals 5. So you divide the displacement by the total time. Yes? You have to memorize. You have to know that. 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 So let's take a look at this right here. What we're doing is this. This is what we're doing here. Let's say that this right here, actually, let's start with something more general. I want to start with something more general. Do you remember that first example we had? What was that first example? The velocity, let's say actually a car just goes 100 meters per second. It's just going 100 meters per second. So let's just say v of t is 100. So 1,000, 100. So what would that velocity graph look like? What kind of line would that be? Well, all lines are straight, so what kind of line would that be? A what? Horizontal line. So it's 100 right here. It would look like this, right? And let's say time equals 0, and then there was time equals 4 right here. This represents, this area right here would represent the total distance traveled, right? If you go 100 meters per, let's say 100 feet per second for 4 seconds, how far have you gone? If you go 100, you go 400 feet, right? That's the area of that box. That's the area of that box. Okay, let's make it a little more interesting. We turned it into something that looks like a line, or let's say the velocity is increasing. This area still represents what? What does that area still represent? The total what? The total displacement. If you wanted to find the average velocity, you're taking this area right here, and what are you dividing it by? You're dividing it, if you're going from 0 to 4, you're going to divide it by 4. So let's go back to this picture here. This velocity function is the one we just used. It was t squared plus 1. What did I say average velocity was going to be? It was going to be the displacement divided by the total time. The displacement is adding up all of this area and dividing it by time. If I do all of this added together and divided by time, do you see this shape right here? What does that shape represent? What does this rectangle represent in relation to something else on the board? What does that rectangle represent in relation to something else that's on the board? Is right here. It looks like it's saying it's 10. You guys got 9 and a what? You know, that just could be a difference in graphing, like 9 1/3 could actually be there just on that. It's a little bit below the 10, so potentially it is. So we thought it was what? 9 1/3, right? The point is 5 times 9 1/3 is equal to 46 2/3, which is the area under that curve, which is the area under that curve. So what do you have here? The height of the rectangle, the base of the rectangle, equaling, when you multiply them together, the overall area. And what do you get to use a whole lot of? You get to use your calculator a whole lot right now to find these exact integrals. It's in fact the only way you have, unless the shape is really basic. Do you remember those integrals we did where it was like a square with a triangle on top? Don't forget your basic algebra. Don't forget your basic algebra. Don't forget it. Don't forget it. Okay, so let's take a look at this. The overall area is 9, right? So if you wanted to find the average value, and I could almost write today, if you wanted to find the average value, you would divide 9 by what? 4 minus what? 4 minus 0. So what's the average value? 9 over 4. So if you go to 9 over 4, which is like 2 1/4, you go 2 1/4 like right here. 2 1/4, let me change the color. So like 2 oh, that's not 2 1/4. 2 1/4 is going to be like right here. If you go straight over, you go all the way to 4 and go down, what are we saying? We are saying that the area of this rectangle right here is what? Equal to the area of the shape, the area under that curve, the displacement under that curve. That's all you're doing. That's all you're doing. That's the rectangle right there. The way I like to think about it is, I like to think about it as, let's say this is a plastic line that you can bend but you can't stretch. It can bend but it can't stretch. If you were to take this thing and pull it out, this is the rectangle that it would make. If you had some curvy function, you do the same thing when turn it into a rectangle. This is the rectangle that it would make. The act of taking the integral is what allows you to find that area under the curve when it's not so clean.